Hi, I'm Charles Low, and I'm an organic chemist as well as a carbohydrate chemist. And I have begun my career in 2016 in Germany at the Max Planck Institute of Molecular Physiology, where I investigated bond forming processes by using novel catalytic methods to synthesize sugars with great precision. And after approximately 8 years of my research in Germany, I shifted to Ireland, where I'm currently at the University College Dublin as an assistant professor. On a personal note, this is a tremendous honor. It offers recognition that innovative approaches that seek solutions beyond conventional fields is appreciated by the broad international scientific community. A lot of scientists, as a fact, in my field, were nurtured to position their long-term research based on prevailing trends. And this award really encourages researchers to come back to their innermost eureka moment and to seek answers to fundamental scientific questions based on the pure passion for the science. And on a professional note, I feel that chemistry as a science is currently undergoing a massive transformation. The old school view that classically segregated chemistry into physical chemistry, organic chemistry, as well as inorganic chemistry is now seeing big changes. And this award, in its essence, recognizes young researchers worldwide who are willing to have the boldness to move out of this box, and in particular by exploring the interfaces between these fields. In my view, it encourages budding chemists to be flexible about their scientific paradigms and to reevaluate underlying assumptions of classical approaches. And I think this is the next big thing in science. The pure inquisitiveness for the science. And for my case, the key question of our research is how we can use underexplored weak interactions, or what we know scientifically as sigma whole-based interactions, similar to how enzymes work, to target specific sites in sugars. And this is a very exciting field because now we can precisely control the synthesis of highly complex carbohydrates. And this has profound implications for health as well as for medical discovery. I was actually trained during my PhD and my postdoctoral phase in a highly traditional organic synthesis background in catalysis, where we explored how we can develop catalysts to accelerate the formation of chemical bonds. And the key paradigm shift for me occurred in 2016, where I started my research at the Max Planck Institute of Molecular Physiology in Germany. And I had to work alongside a diverse group of scientists ranging from chemical biologists, chemists, to biologists. So this forces me out of my comfort zone to explore biologically relevant molecules. And I should mention a very important person in my life, which is my mentor, Professor Herbert Waldman, who has been very instrumental in encouraging me to move beyond classical fields to interfacial research, where the frontier scientific questions reside. And this eventually brought me to explore the molecular logic of how non-classical interactions can result in precision bond-forming processes in sugars. The scientific journey, in true honesty, is one which starts off with a big dream, but takes tenacity to reach the eventual destination. And in this long marathon process, I have to be honest that there will be cheerers as well as doubters. And to be fair, this is part of the holistic learning process. Savoring this process is critical. And there is even a saying that without the critics, one may not fulfill their full potential. And I have to admit that I profoundly agree with that. I encourage young scientists to always remember their initial love for the science and to believe intensely in their ideas. Do not be encouraged by initial failures or even rejections, which is common, and trust that the process will eventually mold you to be a better and valuable scientific contributor than what you initially envisage.